All right, so let's begin. Welcome everyone to today's webinar, Bringing Engineering and Physics to Life with Videos. So in this session, we'll dive into how JoVE can help bring those tricky and abstract concepts in physics and engineering to life, making them easier to teach, learn, and connect with. I'm Lakshmi, a scientific outreach specialist, and I'm excited to guide you through this session today. Joining me here is my colleague, Dr. Stephen, who is also a scientific outreach specialist for health sciences, and he's here to help out monitor the chat and the Q&A boxes that we have as part of Zoom here. And he's going to help us make the session really interactive and lively. Before we get started, a couple of quick notes for all of you here. You can use the chat and Q&A box, as I just mentioned, to share your thoughts or ask questions anytime. Let's keep this really interactive. Closed captions are available, so feel free to turn them on for a smoother experience. Now that we're all set, let's take a look at what we'll be covering in today's session before we actually dive into the session. So we start by discussing the challenges of teaching physics and engineering and how blended learning, especially with video-based resources, can help bridge the gap between theory and application. From there, I'll introduce JoVE and share how it supports educators like you in making complex topics more engaging and accessible. Next, we'll take a closer look at JoVE engineering and JoVE physics in particular, exploring their content and real world applications. Then we'll dive into how you can enhance student engagement using playlists and interactive quizzes, creating a more immersive learning experiences. So these are two powerhouse tools that we have as part of JoVE. To make implementation seamless, I'll also walk you through the embedding of JoVE videos into learning management systems that you must be using. So we'll today be talking about the widely used platforms like Moodle and Canvas, so ensuring easy access for both you and your students. Finally, we'll wrap up with a question and answer session, and it'll be an open forum where you can ask questions, share your insights, and also discuss the best practices with the fellow educators here. All right. So picture yourself teaching your students about gravity. Um, you've explained about how objects fall when dropped, a fundamental concept that sets the stage for deeper exploration. But then you introduce something more advanced, gravitational time dilation. Suddenly, you're faced with a challenge. At this point, you turn to the chalkboard, breaking it down step by step. The board starts filling up with equations alongside rough sketches. For some students, this is where the aha moment occurs. But for many, this is where things really start to feel distant, isn't it? Because it's a lot of theory and hard to grasp. Now, this is where the classroom suddenly feels dull and disengaging. Students lose focus, the energy in the room dips, and what started as an exciting discussion, a real world question, turns into a lecture without a spark. Now, here's a question for all of you. How do your students typically react when you start explaining something that's highly theoretical? And do they stay engaged or do you see them zoning out? Drop your thoughts in the chat. I would love to hear from all of you. Hmm. Interesting. So I see a mix of responses coming in. Some students love the challenge, zoning out, right? So that's what most of you have experienced. Yes. So while most of them start drifting away when the explanation gets too technical, and like you have rightly mentioned, they really seem zoning out. So that's something we've all experienced. So it's clear that while students are eager to learn something new and something exciting, some concepts just don't click right away. And when that happens, we risk losing engagement. Now, before we move on, so how would you teach this concept in alternate ways? So, we would love to hear the alternate ways that you have already handled with, or you would love to try in your classrooms for some topics like this. Can you please, feel free to write down, type your answers on the chat box. So, would you use diagrams or maybe some analogies, or maybe just walk them through the equations, step by step? What's your go-to method? Wow. Okay. So these are, yes, so they are in lines with what we're going to discuss now soon. So there are some creative teaching approaches that I can see, like modeling on the board and, trying showing some YouTube videos. Exactly. Something in lines with visualization. Great ideas. So please keep them coming. Physics faculties and of course engineering faculties always have the best analogies. So I'm really excited to hear yours. Yes, exactly. So modeling, simulations, and all of these. So now, uh, instead of diving straight into the math, like all of you said, we could try some alternative approaches. Like some of you have mentioned, try showing something visually appealing to them. So what if you showed them a scene from a movie? So maybe, Interstellar. Take Interstellar, for example. The crew lands on a planet orbiting a supermassive black hole where time moves differently. So the film brilliantly portrays this effect that we're trying to bring into the class. 1 hour on the planet equals 7 years on Earth. So that instantly captures attention, doesn't it? In just a few or a couple of minutes that the clip is being played, students feel the reality of time dilation. Suddenly it's not an abstract concept to them anymore. It's something that they can visualize, relate to, and maybe even feel. But here's the catch. Films like Interstellar are definitely great for sparking curiosity, but they're not designed for wholesome education, isn't it? So that's where JoVE comes in. It provides scientifically accurate, curriculum aligned videos that take complex physics concepts and break them down in a structured, engaging way, ensuring students just don't see the effect, but truly understand the science behind it and are able to appreciate what's really happening inside. So, Jove videos go beyond just explaining, as we've just discussed. They show how these problems and principles apply to the modern technologies and much more. So, this helps students bridge the gap that we have just seen in between the theory and practice, making their learning more meaningful. So, for educators like you, Jove is an efficient time saver with ready to use videos that are peer reviewed, interactive quizzes, and seamless LMS integration. Plus, all the content that we have is something that I would like to repeat again is peer reviewed and scientifically accurate, ensuring quality. And here's an important challenge that students come from, diverse backgrounds, and technical jargon can definitely be overwhelming to them. Visual learning helps cut through these language barriers, isn't it? Allowing students to focus more on the science instead of just decoding the dense textbooks that they're loaded with. So Joe isn't here to replace your teaching, definitely not. It's here to enhance it. So by adding videos to lectures, assignments, or even say open discussions that you have in your classrooms, you're giving students a powerful tool to truly understand and retain the complex concepts. So we'll dive quickly into engineering and physics in particular to see how these subject-specific videos can bring your classroom to life. So on whole, JoVE is a compilation of 18,000 plus videos across various disciplines ranging from health sciences, biology, chemistry, engineering, physics, and so on. We publish 500 plus videos every year. We are evolving. We keep ourselves updated to the current trends and advancements in science and technology. We have a large subscriber base of 1,000 plus institutions with 8 million plus users. All of our videos cater to multiple languages with both the voiceovers and the subtitles or the transcripts in different languages. And we also have a huge base of protocols. So we talk about the lab manuals in detail once I walk through the website. So we'll quickly dive into the website directly. This is how the JoVE website looks like. So it's jove.com, and you come into the engineering part of it. So you have, again, JoVE has two sections, largely JoVE Core and JoVE Science Education. Engineering is an extensive collection. So it's a comprehensive video collection that we have here. It offers a structured approach to teaching fundamental engineering disciplines like mechanical, electrical, civil engineering. And so when you go on deeper into science education, you also can find bioengineering, aeronautical, structural, chemical, and so on. So these videos that you see here, so say I click onto any of this particular one, so you can find again a lot of videos with experiments that are being performed live. So these videos simplify complex topics to visual demonstration. And so all of these here are experimental techniques and real world applications, making it easier for students to grasp the critical engineering concepts. So whether it's biomechanical strain analysis or aerodynamics that you see over here, or materials characterization, JOVE's expertly designed resources aligned with the academic standards, ensuring an engaging and effective learning experience. By integrating these videos into your coursework, you can complement the traditional teaching methods that you've already been following with a dynamic interactive learning tool that brings both engineering and physics to life. I'll take you through geophysics as well. So yes, geophysics also has GeoCore and geoscience education. So this is again another comprehensive video collection to support a wide range of topics. So GeoCore physics spans 33 chapters with 498, so almost close to 500 bite-sized videos. Each of these video focuses on a single concept using conceptual animation and problem-solving applications to enhance comprehension and retention. So the Job Science Education again, which we saw here, it explores the classical mechanics in a much deeper extent, like electrostatics, magnetism, circuits, and all of this, connecting theory to practical applications for diverse student populations while helping educators to bridge the gap between the abstract principles and real world applications. So that's an overview about how geophysics and geoengineering looks like in our website. So that's a repository of the videos that we have. And so now that we've got an overview about how Joe videos bring complex concepts to life. How do we ensure that students retain and apply what they have learned through these videos? So this is where the interactive tools like quizzes and playlists, the curated playlists, play a crucial role. So Jove's curated playlists offer a structured way to integrate video resources into coursework, ensuring a seamless learning experience for students. So as I click this, so these are created by our team of subject matter experts. These subject-wise playlists that you can see over here. So this is for business. You can just type in any title that you want. Say I type in semiconductor and then you find playlist for semiconductor. So all of these are curated, but you can also tailor your own playlist, and we're here to help you to do the same. And so these are ideal for supplementing the lectures that you take or assignments or even the flipped classroom models by embedding playlists, which I'll show you very shortly. So by embedding these playlists into your LMS platform, you can enhance lesson planning, provide on-demand learning, and create a more engaging and interactive classroom experience. So be it, reinforcing the core principles that you're bringing into the classroom, or if you want to introduce some advanced applications. So the, playlist should be your go-to because it should have everything from the basics to the advanced of that particular topic that you're trying to bring into the classroom. And when we go back to quiz, so JoVE quizzes are they are an excellent tool. They provide a ready to use assessment tool that helps you to evaluate the students understanding of key concepts. You really want to assess them on the go. You want to know if they're really learning in something from the videos that you're showing to them in the classroom. So this is a comprehensive quiz bank that we have here, and you can save a lot of time on assessment creation while ensuring that questions align with the learning objectives. You can also tailor your own quizzes. You can, in fact, combine multiple concepts into a single assessment, reinforcing a deeper understanding. Plus, with an intuitive and user friendly interface that we have here at JoVE, these offer a smoother experience compared to the traditional LMS quiz builders. So that's an overview about the JoVE playlist and quizzes that we have as two interactive tools. And now let's take this a step further and explore how do we make the resources that we just had an overview about easily accessible within your already existing course structure. So this is where JoVe's seamless LMS integration comes in. So JoVE integrates effortlessly with major learning management systems like Moodle, Canvas, and Blackboard, allowing educators like you to embed videos directly into the course materials. Instead of students jumping between platforms or searching for links, everything stays in one place. Beautiful, isn't it? So, creating a streamlined learning experience. A key advantage of embedding videos in the LMS that I really want to emphasize on is that students don't have to create separate Job accounts. They can access content anytime, even offline, through the LMS platform that you've already been using. So, this makes learning more flexible and uninterrupted as well. So you can just quickly go and also track the student engagement, assign videos as coursework, organize content efficiently. You can plug in the playlist, and you can also integrate the quiz, everything into the LMS platform. So we'll dive in directly to the website. I'll just take you deeper into the website. So as I said, this is how the homepage looks like. So it's jove.com. And yeah, so JoVE is built on two main components, like I said. So we have JoVE Research and JoVE Education, each designed to support different aspects of learning and discovery. JoVE Research includes JoVE Journal, which is a peer-reviewed multidisciplinary scientific video journal indexed in PubMed and Web of Science. And JoVE EOE, which is Encyclopedia of Experiments, is an online video encyclopedia showcasing advanced research experiments for scientists in academia and biotech. Now, coming to the other side, which is JoVE Education, we have multiple disciplines here, as I mentioned to you. It features JoVE Core, which acts as a video textbook using animations and real life experiments to explain undergraduate and graduate concepts. JoVE Science Education is a video library of demonstrating scientific experiments virtually. And JoVE Lab Manual, it's an all-in-one teaching tool for any of the lab courses that you want to teach in the class. Now, all of these videos that we're talking about here, they are mapped to widely referenced physics and engineering textbooks. And these you can find them here at the Faculty Resource Center. And these are available, here at the FRC, which is Faculty Resource Center. And they act as an excellent supplementary material for students. Like once you show them the video, they can also go back and refer to the textbooks that we have here. So I'll just show you. So they are mapped to textbooks. Say I take engineering, or say maybe I'll take in physics. So you can see, yeah, there's a wide list of textbooks that the videos are being mapped to, and these are mapped by our subject matter expert team. And so it's a detailed mapping of the videos that we have done here that aligned with the course curriculum. And we'll go back. So, yeah, now that we'll go back to physics again, we just had an overview. So, Joe Physics, as I like I said, yeah. So geophysics is a collection that offers concept-driven animations and real-world demonstrations to help students grasp fundamental principles more intuitively. And Jove engineering, on the other hand, that we also had an overview about. So it's extends beyond the core physics principles. It's applying them to real-world engineering scenarios. So you'll find topics like thermodynamics or gravitational fields, material science, electrical engineering, mechanical, civil, structural, all explained through engaging videos that make complex theories more accessible. So, speaking of accessibility, let's revisit our earlier discussion on gravitational time dilation. So, rather than just picturing how time slows down in strong gravitational fields, let's see it in action, right? So, I'll play a short clip from Jove that visually demonstrates this concept, making it much easier to grasp than words alone. I'm going to play this
In
for a
Newton's gravitational theory, the gravitational force acts instantly across empty space between any two widely separated masses. However, the speed of light is an upper limit for any physical interaction. Newton could not explain why the mass used in the law of gravitation is the same as inertial mass used in his second law of motion. Einstein stated that since gravity and acceleration are equivalent, the two masses are the same. He addressed the contradiction for speed of light by re-envisioning space as an invisible fabric called space-time, having 3 spatial dimensions and 1 temporal dimension. He proposed that in the presence of a large mass, this fabric curves and wraps around it. Therefore, any smaller mass follows the shortest path around the larger mass on the curved space-time fabric. During a total solar eclipse in 1919, a star behind the Sun was visible slightly away from it, as predicted by the general theory of relativity. This observation proved that the light from the star followed the shortest path on the curved space-time around the Sun.
There you have it. So that's the Joe difference that we've been talking about. Concepts that were once abstract and complex become visual, engaging, and easier to grasp. Now, science is complicated enough. So why make it harder by struggling with the language barrier, right? So we all know that concepts just click when they are explained in a language we are comfortable with. So that's why Job's videos come with subtitles and voiceovers in multiple languages, like I said. So you could
In
choose
Newton's
playing
gravitational theory,
this in any other language. So why don't we just try in a native language? Uh, maybe, you know, Italian. We'll just take a snippet and just play and just see how it sounds
La
like.
forza gravitazionale agisce istantaneamente attraverso lo spazio vuoto tra due masse ampiamente separate. Tuttavia, la velocità della luce è un limite superiore per qualsiasi interazione fisica. Newton non poteva spiegare perché la massa usata nella
All right. So no worries, even if you didn't understand, just pretend to look impressed. So you see, science in your own language just makes everything smoother, kind of like how coffee makes morning lectures bearable, right? So with Job, students don't just have to wrestle with, unfamiliar terminology. They can focus on understanding the actual science. So that's why we have this excellent provision to have the voiceovers in different languages. And I'll just walk you through the tabs that we have over here. On the right side, you can find the topics and the other videos that are relevant to the one which is being played. And we have an option to embed this video. We'll shortly go through that. You can add this to a playlist. Like I said, you can tailor your own playlist. You can create a quiz here. And you have the transcript to make comprehension better for the students. We also have some keywords that are being tagged here that are relevant to, again, the video that's being played. And you can just quickly go and, click on any of this and that will link you to the next video. So that's an overview about the Joe video that we have here. So this is from the Joe Core Physics repository. Now, let's choose a widely used LMS. So first, let's say, be it Canvas. I'll just show you how to quickly embed the same video. So what I'm going to do is I'm going to first click on embed video, and that's going to, yeah, copy the code here. I'll go to the Canvas platform and go to pages. Yes, I'm already on pages. So I'll add a new page, and what I'm going to do is add a title. So I'm going to add this as space-time curvature test. And yes, so when I come down here, I see the HTML editor. Then just going to paste it over here. And yes, it's as simple as that. I'm just going to save and publish. Yes, here it is. So it's beautifully embedded, integrated into your LMS platform. Now, say I want to, embed a whole playlist. So what I'm going to do is I'm going to go back to JoVE, um, say anywhere. Just going to click on playlists. We already have it here. So basics of semiconductor. Then I'm going to click on downloads. So that's going to download the playlist for me as a CC file, which stands for common cartridge. And yes, it's downloaded. I go back to the LMS. Then you go to settings, scroll all the way down, go to settings. And to the right, you see an option called import course content. The content type that we have here for today is common cartridge. And then you choose your source file, which is just uploaded. Yes, basics of semiconductor. Then click on all content. Then import. That's it. So maybe it takes some time. So I'll just go and show you how it looks like while it's running. So you go to modules. I have already embedded. Yeah, it's the same thing here. I've already embedded the same playlist, basics of semiconductors. So that's how it looks like when it gets integrated. You can then go choose to click on any of the videos. And so when you integrate a playlist into your platform, you also get the transcripts here, which are definitely great for comprehending better, as opposed to a standalone video being embedded onto your LMS platform. So that's the beauty of embedding a playlist. And as I said, your students don't have to create separate accounts, and they can access it anytime offline 24/7. Now, we'll just try again, maybe with another widely used platform, which is Moodle. So what I'm going to do is, so this is how your Moodle dashboard looks like. I'm sure whoever is using it must be very familiar with such a dashboard. Now I'm going to click on topic, any topic, and just click on add an activity or resource. Go to page. Then same thing here again, space, time. So test, and then I don't have to type any description. Yeah, in the content, I'm going to click on the HTML editor again, and wherever your cursor comes in, just paste the code over there. And yes, that's it. Save and display. And there it is. We have the video embedded. And so say I want to, embed a playlist again. So I choose a topic, any of the topics, add an activity or resource, then go to the IMS content package. And again, here it's the same thing. So say it's a test playlist that I'm trying to, and again, you can leave the description or you can just add in anything and choose a file here. So upload the file. So it's the same CC file that you're trying to upload. And that's it. Save and display. Yes, so that's how easily you can integrate into any of the LMSs that you must be using. So we, since we have some time constraints, we have just demonstrated the Canvas and Moodle today. So in Moodle, you also get this table of content where you can actually browse through the different topics again as part of the playlist. And yes, like I said, you will also have the transcript when you're integrating the playlist as opposed to the standalone video. So that's how seamlessly you can integrate JoVE's video into your already existing, course structure platform. So this integration makes it easier for you to assign videos as part of your coursework, track engagement, and ensure that students have on-demand access to high-quality, peer-reviewed content, all without leaving the LMS. So before we wrap up, let's take a moment to summarize what we explored today. So, we saw how Joe brings physics and engineering to life with engaging videos, making abstract concepts or something that's very complex more tangible. So we also looked at playlists, quizzes, and the seamless integration into your LMS platforms, giving you practical ways to enhance student learning. Now, looking ahead, as you can see on the screen, we have sessions planned for March and April, focusing more on specific topics in physics and engineering, like the one in March is on motion to see more about the kinetics and kinematics in play. And the one in April is more about the core electrical engineering concepts. So these webinars run every month, all throughout the year. So there's always something new to explore. So keep an eye on your inbox for announcements and registration details. You can sign up for the ones that are most relevant to you and continue bringing engaging visual learning into your classrooms. So with that, I'd like to thank you all for joining in today's session. I hope you found it insightful and that you're really excited to explore Joel's resources further. So I'll open the floor now for question and answer sessions. So please feel free to drop them in the chat or the Q&A. Stephen is also here to help us out, read the questions and we can take it up alive.
All right. Thanks, Lakshmi, for an engaging and informative presentation. So thanks everyone for typing in your questions. So we have a few questions here. First question is Joe aimed more at higher and further education rather than secondary school level?
Yes. So since again, like we had a constraint on the time, we didn't dig deeper into all of the contents that we have. But yes, definitely talking in particular about geophysics and engineering. So all of the video content that we have, or even the science education materials that we have, they vary from the core principles to the advanced topics. So they definitely cater to higher education. And we have mapped the textbooks also not just to the undergraduate courses, but also to the graduate level courses. So they definitely cater to different levels. And even if you find something exciting that's not covered in JoVE, we are always happy to listen from you. And we are always working on adding in more content.
All right, thanks, Lakshmi. So there's one more question. Can we find somewhere how to introduce and model step by step? So that's the embedding process. You can maybe share about the FRC.
Yes, exactly. So I hope you just got an overview, by what we did today. But we have this Faculty Resource Center. You go to, maybe I can just quickly show it again to you. You quickly go to, give me a minute. So you quickly go to the JoVE website here, and then you have something called the Faculty Resource Center, which contains a huge collection of documents to aid you into seamlessly integrate all of these videos to the LMS platform that you are using. So we just talked about the ones which are widely being used in Moodle and Canvas. Even if somebody is using some other platform, though the principle is going to be the same, you're just going to copy the code and embed it over there. But the step-by-step procedures are all mentioned over here. So you can just go click in and it's all step by step, like you said. So yeah, that's where you need to go and check. And you can also reach out to any of us. You can just drop us an email. We'll be happy to assist you in doing the same.
And thank you, Lakshmi. So one last question we have here is, are Joe videos regularly updated to stay relevant?
Yes, like I said, so JoVE continuously adds new content and updates existing videos to reflect the advancements in science and engineering education. And like I said, even if you have some topics that you would really like to see on JoVE repository, please feel free to reach out to us and we're happy to integrate them onto our repository.
All right. Yeah, I think that's all we have on the chat box and also from the Q&A.
All right. So thank you everyone for joining in the session and making it really interactive today. So we're looking forward to seeing you in future webinars. Thank you, and thank you, Stephen.
Sure.